Hello viewers, welcome back. Today we're going to look at metals. So under metals, we are going to look at the general properties of metals. How are these metals working? What is the function of these metals? That's what we're going to look at metals. We are also going to look at extraction of iron, extraction of copper, and extraction of zinc. Then by so doing, then will be done by metals. So now, first we are going to look at the general properties of metals. So what are the properties of metals? One, metals are ductile. Okay, what do I mean when I say metals are ductile? So metals are ductile in the sense that these metals that we see, that they can be easily drawn into wires without being deformed. So these wires that we use daily, they are formed from what? From different metals. Because a metal is something which is big, where they just break up the metal and make wires. Now that process of breaking that metal to make wire is what we call metals are ductile, because they can easily drawn into what? Into wires. Then this is the first property. Then second, we have metals are malleable. Metals are malleable. What do I mean? Metals are malleable. This simply means that metals can be drawn into iron sheets without breaking. Metals can be drawn into what? Iron sheets without breaking. Then the third property that we have under metals is that metals are sonorous. Metals are sonorous. The spelling for sonorous is this one, guys. So metals are sonorous. So what do I mean here by saying metals are sonorous? Let's say for example, we bring a metal here, then we do like this on the metal. The metal is going to produce the what? The sound. So by so doing, you say metals are sonorous. That's one of the properties of metals. Then we also have the fourth property, which says metals are hysterous. Metals are hysterous. What do I mean by saying metals are hysterous? So metals, when they are being polished, they make sure that they shine. That's what I mean by metals are hysterous. The last one, the properties of metal. Metals are solid at room temperature. Metals are solid at room temperature and pressure. Apart from mercury, which is the liquid at room temperature room temperature and pressure. So these are 5 properties of metals that we have under your level, guys. So there are just 5 properties of metal, where the first one is metals are ductile, which simply means that metals can be drawn into wires without breaking. Then second, metals are malleable, which simply means that metals can be brought into iron sheets without breaking. Then the third one is metals are sonorous, then which means that metals can produce what? Can produce sound. Then the other one is that metals are lustrous. Metals are lustrous. This is lustrous. Metals are lustrous. So meaning they shine when they are being polished. Then the last one is that metals are solid at room temperature and pressure, apart from mercury, which is the liquid at room temperature and pressure. So these are the properties of metals that we have. So now coming to its to their reactivity. When we go on the periodic table, at the far right there, we find the what? The metals. Now, how is the reactivity of these metals that we find on the what? On the periodic table? So let me draw this curve just to illustrate the reactivity of these metals. Let's say, for example, here we have potassium, here we have sodium, here we have calcium, here we have magnesium, we have aluminium, we have zinc. These are all metals. Then we have iron, then we have lead, then we have copper. So the reactivity of metals is that as we are increasing the atomic number, the order of decreasing of reactivity. Decreasing reactivity. So what do I mean? As they are increasing going this side, meaning they are decreasing in their what? In their reactive. So meaning this copper which is down here is more reactive compared to lead that we have here. So this one which is on top is the one which is least reactive, meaning it is reactive at a very small rate. So now this is just the order of their reactivity. So after this, let me go and look at the reactivity, or let me go and look at the extraction of what? The extraction of metals. Extraction of metals.
Restore your chats. Enter your PIN to get your end-to-end encrypted chats on this device.
Let's look at extraction of metals. Extraction of metals. So, metals are obtained from their ores. Metals are obtained from their ores. Take note. There are 2 types of extraction of metals. There are just 2 types of extraction of metals. The first one that we have is reduction. Then the second one is electrolysis. So all these metals, they are being extracted using these two methods. Then, what's really involved with reduction? What's really much involved with reduction? Reduction is used to extract less reactive metals such as copper, iron, and zinc. So this one is used to extract less reactive metals. So if you have less metals like copper, zinc, and iron, we use reduction method to do the extraction. Why are we using reduction when extracting zinc, copper, and iron? Because copper, zinc, and iron are less reactive metals. Then, when do we use electrolysis? When do we use electrolysis? We use electrolysis when we are extracting more reactive metals. We use electrolysis when we are extracting more reactive metals. Now, for example, of more reactive metals, we have sodium, we have potassium, and aluminium. So these are just the examples of metals that we can extract using what? Electrolysis. These are just examples that we can use to under electrolysis. So after this, let's look at the extraction of iron. Let's look at the extraction of iron. And we know the process that we use to extract iron, which is reduction. We know the process. So let's go and look at the extraction of iron. Extraction of iron. So this iron, it's being extracted from its abundant ores, which are magnets, and hematites. So we can write this as F2O3. So this is magnetite and hematite. So we extract iron from these two. So zinc is extracted by reduction using carbon monoxide as in a blast furnace. So this iron is being extracted using reduction method. Why are we using reduction method? Because iron is less reactive. That's the reason why we are using what? That's the reason why we are using reduction method. Now this iron is being extracted from the what? From the blast furnace, using carbon monoxide as a reacting agent. Now, how is it going? How is it being done? This one. Let me illustrate to you how is it being done. How we do the extraction of iron. Let me illustrate you. Let's say, for example, this is our blast furnace. Let me just draw a simple blast furnace here. Let me draw a simple blast furnace so that we bring the understanding. So this is just a rough diagram of the blast furnace that we use to extract iron. Yeah, something like this. Then here we have this. Then here we have this. We have our temperature, which is 400 degrees Celsius. Then you have these arrows. Don't worry, you understand these arrows. Then we have so this is just the example of a blast furnace that we use to extract what? That we use to extract copper. So the thing is that here we put the raw materials. Now what are the raw materials that we put here when we want to extract this iron that we are talking about? You put coke. Someone will ask me to say, what is that coke? When we say coke, what we mean carbon. We also put iron ore. We also put iron ore. Then, not only that, we also put limestone. So these are the three things, guys, that we put in the water as the raw materials here. We put them here. Now, after putting them here, what do we expect? What do we expect now? These coke, iron ore, and limestone, they are going to be boiled by the heat which is coming from here. They are going to be boiled. When they are being boiled here, they are going to escape. They are going to release what? They are going to release some heat. Now, this heat which is coming out here is what we refer to as waste products. So this is waste products. Even here we have the waste products. So these are the waste products. So someone wanted to say, why is this blast furnace not get heated? Because this heat is very enough here. It can heat this. Now the thing is that this walls of the blast furnace is made out of what? It's made out of steel. This blast furnace is made out of what? Steel. Which is a heat resistor. It is a heat resistance. So steel is a heat resistance. No heat can melt the steel. Then after this waste products, guys, it goes out here. So meaning again, it is going to come out like it's going to go in like this. It's going to enter here again as hot air. It is going to come like this. Then it's going to enter here as hot air. Then here we find the temperature about which is about 1800 degrees Celsius. When you look at this temperature, guys, this is very enough temperature. So down here, it goes after this air has entered again into the blast furnace, it is going down here, where here it is going to form the what? The molten slag. The molten slag here. Now molten slag which is being formed here, it has a lot of uses. I know most of you have already seen the tar rod. So that tar that you see on the rod, they get it from the what? From a section of iron as the molten slag here, because they don't have any use here. So they get them from here and use to make what? Used to make tar rods. Then here now, so here is where the molten slag is coming out. Here is where the molten slag is coming out. Molten slag. Then here now, finally, we receive iron. So all this process which is being done here is how iron is being extracted using reduction method. Why reduction method? Because iron is less reactive metal. So let's look at the uses of this coke, iron and limestone. What is the uses of this coke, limestone? Coke, which is also known as carbon. Allow me to erase this so that I write the functions of these that we have written here. I remember we had coke as a raw material. We had coke and limestone. So, what is the use of coke and limestone in a blast furnace? Coke is used, so this coke is used to form carbon monoxide. This coke is used to form carbon monoxide. Then, what's the function of limestone? What's the function of limestone? Remember, at first, I said in the blast furnace we put coke, iron ore, and limestone. So this iron that we are extracting is in what? In iron ore. In iron ore. So, meaning coke and limestone, they just help us in order so that we extract this iron at the end of this. Then we also have hot air. There's hot air which is coming now at the end of the blast furnace. Down there, there's hot air. What's that function of hot air? Is to heat iron. That air, we use it to heat iron. Then 3, we have waste. We have waste gases. We have waste gases. These are the ones that are being released at first of the blast furnace. They are being released waste product. Now, what's the function of waste gases? These they work as to heat the incoming air. These they heat all the air surrounding the what? That blast furnace. So that air which is coming now, which is coming in, so that it heats well the what? The iron ore. Then 4. What's the function of molten slag? I think I've already explained about this. So this is used as rod making. So this molten slag is used when making roads. Then we also have steel. We also have steel. So I remember I explained about the steel on the breast finance when I started explaining. It's made out of steel. The walls of breast finance is made out of steel. So why steel? To avoid or to prevent the furnace, from melting, because of high temperature, because there we are dealing with high temperatures. So that's the reason why we use steel. So now after we have looked at how iron can be extracted, now let's look at the processes which are involved in the extraction of iron. We are still looking at iron. The processes which are involved during the extraction of iron. Processes involved in the extraction of iron. So it's not like we just extract this iron without a process. No. There's a process that we follow when we are extracting this iron. So the thing is that when carbon is in which state? It is in solid state. When this carbon reacts with the oxygen gas, when carbon reacts with oxygen gas, they always form carbon dioxide. And this carbon dioxide is in gaseous form. So now, this carbon that you are seeing, carbon dioxide, it also reacts with what? It reacts with carbon, which is a solid. Now, when these two react, what do they form? They form carbon monoxide. Now, how do you write carbon monoxide? We write like this: carbon monoxide, which is a gas. So guys, in chemistry, whatever we do, when we have such kind of an equation, we make sure that it is balanced. So what do I mean? We make sure that whatever we have this side is the one that we need to have this side. So like on the product part, we have carbon 1. We have 1 carbon here. We also have 1 carbon here. Coming to oxygen, we have 2 oxygens here, and here we have 2. So meaning this equation is what? It's balanced. Then let's come to the next equation. If we look at it, if it is balanced, here we have carbon, here we have carbon. So meaning we have how many carbons? We have 2 carbons. Here we have how many carbon? 1 carbon. So we can put a 2, temporarily a 2, to balance it. So meaning here we have 2 carbons, meaning here we also have 2 carbons. Then we have 2 oxygen, here we have 2 oxygen. So meaning it has been balanced. So we put a 2 here. That's what we do in chemistry. So, not only this, so this carbon monoxide, in our case, it is acting as a reducing agent. It is acting as a reducing agent. Now let's look at the uses of this ion. We have been talking about metals, we have talking about the properties of metals, we have been talking about the extraction of ion, the processes which are involved in extracting ion. Now, what are the uses of this ion that we have been talking throughout? So the first use of ion is for making alloys. Second is for making magnetic. So someone might ask to say, what is an alloy? What is an alloy? An alloy, this simply means the combination of metals. Alloy is the combination of metals. Then we also have a word which is a bit challenging here, which is electromagnetic. What is electromagnetic? Electromagnetic, these are just substances that lead us to magnets. Let's say, for example, here we have this metal. This is metal A. Here we have metal B. For these metals to do the attraction or the repelling, meaning there are magnetic field or magnetic force which is making it not to attract and to attract. So this is all about ion. So any question under ion, just drop the comment or WhatsApp me on the line 097 64 346. Any problem under ion after watching this video, just text me on WhatsApp using this line, which is 097 64 346. Thank you, and don't forget to subscribe so that wherever I upload a new video, it will be able to reach you wherever you will be. Thank you.